So if you're ready to hook up to this tutorial for the personal training, I would say you should just follow the link down below this training and join our Ekidel Mentorship Class. Okay, so thank you. Okay, so right now, looking at this, you can see that this is our building plan that we got from the design architect. So first of all, once you receive your plan from your building architect, the first thing to do is for you to now identify all the features involved in that plan. So first of all, you have to copy the plan separately. Just try to have a copy of it so that in case you don't make any kind of mistake, you'll be able to now at least have a reference. Okay. So the first thing to do
Yes.
is to now understand all the features on the plan. So looking at this right now, the features here is that this plan, this is the ground floor plan, and then this is the first floor plan. So on this ground floor, this building have a cantilever, as you can see it here, of 900, or on this other end, this side, and also on this side, it also have a cantilever. So let me just check the length of the cantilever. You can see that this is 600, while this is 900. So we have now known that this place has a cantilever of 600 at this very
Yes.
end, and also at this place here, you have 600 cantilever here, which you can also see it here on the view area. This is the one of 900, and this is the one of 600. Okay. Also, from this
Yes.
plan, you can see that this plan came with a column, circular columns, which I think the main reason for that is to give beauty to this plan and to this building. So there is no way you are meant to tamper with these columns, either to remove them or any other thing, because they are there to give beauty to this building. Are, are you saying that?
Yes.
Okay, so
Yes. Yes.
once
Yes. Okay.
okay, then again you have to also identify where you have your staircase. Like in this case right now, this place is our staircase. So since we have a staircase here, there won't be slab here during our design, because here should be a void for the
Yes.
staircase.
To be open at the top.
Okay, so once you have known all that, the next thing to do is now make your plan look neat. So you have to remove all these symbols that came with the plan, all these furniture plans and all that. So take them off and make your plan look very beautiful. Now, so right now, at this stage right now, we are trying to perform what they call GA drawing, which simply means general arrangement drawing, which also means preparing your plan for what they call framing, structural framing. All right. So I'm going to take off all these
Yes.
things which are not necessary. So I'll do that very quick right now and take this off, and also all the dimensions should be off, and then take these ones also off. Okay, I can leave the first floor. So right now, you can see that I have removed all the things which are not necessary from this ground floor. Then also, we do our structural framing, which is GA drawing, on our ground floor and not on the first floor. When I mean by GA drawing, I simply means column positioning, or what they call paneling. So we have to now position all our columns on the ground floor, and also panel this building on the ground floor. Now, also, if you look at this building, this shape here, you can see that this plan came with something like a curved shape here. Although I will show you what to do
Yeah.
here, either to consider this as a beam or just to run our beam straight all the way around. Okay, so first of all, before I begin
Okay.
to like talk about all this, I would say that I like to perform my design based on frame. When I mean by frame structure, I simply means positioning my columns, and then also knowing how my beams will I run, and also know how my slab will be placed. So with this right now, and since we are using a software called Protastructure for this design, Protastructure have some rules. If you are to export this plan into Protastructure, there are some rules that at least you are meant to follow, and that rule is that you have to create layers for your column and for your grid lines. So when I mean by creating layers, you have to just click on, I don't know if you know how to create layers on this software, AutoCAD, but at least if you don't know, just type layer, and then it will show
I
you.
know how to do that.
Okay, so it will show you a dialog box. So I'll have to create two layers. I'll call it column and then call again the other one grid line. So I'll go right now. I have that layer already here, which is column, as you can see it here. And I also have another one again called grid line. But if in case you don't have, if it's your first time, you're like creating a grid layer for that. I would say that you should create this layer called column and then layer called grid. Okay, so right now I'm gonna first of all begin to place all my grid lines, which also means axis. So I'll go here right now, activate my grid line. Okay, so the first thing to do is to place this grid line at the midpoint of every walls. Like this is now a wall, so I have to create this grid line at the midpoint of this wall. So I'll quickly go and then and while creating this your grid line, don't use a line to like create it, else it will not show on the software Protastructure as a grid line. So you have to use what they call construction line. So as you can see it here, construction line, or you type the shortcut SL, which also means construction line, and then type enter, and I'll say V for vertical. So if I want to place all my grid for like vertical, I'll just say XL, enter, V, enter. Don't worry, I'm already recording this on screen right now. So by the end of this lecture, I will like send you the video. All right?
Okay.
Yeah, if in case I'm like too fast. Okay, so right now again, so you have so I want to create all my grid lines, vertical grid lines. So I'll type XL, enter, and V, enter. And then I will just go and place at the midpoint here. And when I do that, I have to confirm if this line is at the center. So I have to dimension just one here. I dimension this. This gives me 112, and this again, if they are the same, because the width of this wall is 225. So I don't know which block wall you guys use in your country. Whose size of block wall do you guys use?
Mm, in South Africa, it's 220, but
Okay.
in Zim, it's 230.
Okay, that's fine. That's fine. We here in Nigeria we use 225 or 230, which is still okay, not that far. Okay.
Yeah, it's still fine. There's a difference of 5 millimeter or something.
Exactly. Okay, so right now I have now established my first grid line, as you can see it here. So I'll have to do again to I'll just copy this one right now. Since all my blocks they are all the same 225, I'll copy it, taking a reference point from this edge, and I'll begin to place all the grid lines at the vertical walls, as you can see what I'm doing here right now. So by the time I'm done with all the vertical, I will now begin to create for the grid lines for my horizontal ones. So right now I am done with the vertical ones. I'll do again XL, but this time I'll type H, which means horizontal, and I'll press enter. And I'll go and click and find the middle, and I'll check again if this is the same. And I'll check this and check this, which indirectly they are just at the middle. So if I confirm this right now to take the middle, yes, it's at the middle, as you can see there. So I'll go again now, copy this again right now, CP, using CP, and then using the reference point here and begin to paste. So I'll go here right now and paste, and then I will paste here also, and I'll just paste it directly at all the walls which are horizontals. Okay, I'll just paste that here and then do the same thing here and then do the same thing here. This stage, this grid line stage does not require manual principle. It is during the column positioning and during the paneling, then we'll now begin manual principles. All right. Can you hear
Yes.
me? Okay. So right now you can
Yes,
see
I can.
that we are done with placing our grid lines, both the vertical grid lines and the horizontal axis or grid line. So right now you can see that since we used a construction line to like create this our axis or grid line, you can see that they don't have ends. So we have to now trim it off. So I'll just take a rectangle here and then just use my eye gauge and form a boundary for this so that I can be able to trim it off from that boundary. So I'll just use my eye gauge and keep it this way and then click on this rectangle, type TR, which means simply trim. TR means trim, is a shortcut. I use mostly shortcut. I don't like using all these icons, so I'm very good at shortcuts. So I'll just type that and then trim that off and then take this off. So right now you can now see what we have just created. Let me now move this out from this point and keep it here. So we are now done with creating our vertical grid lines and also our horizontal grid lines. Now it is now time for us to now enter into column positioning. So with that right now, I'll have to also go here again and then change to column layer as you can see here. So I'll go and click on column layer, activate that. So with this right now, I have to also create my column. Why? When you're creating your columns, that don't go and use line, because if you use line to go and create your column this way, the software Protastructure will not be able to see this as a column. So always use, I would say you should use rectangle to create your column, or you use polyline to create your column. Because if you're going to export this to the software Protastructure, the software requires that the column, that column icon must be a single unit. But if you use a line to draw that, it will not be a single unit. As you can see that there will be difference, as you can see it here, it's not a single unit, right?
Yes.
Okay, so that software requires it to have a single unit just like this. As you can see, this is a single unit object. So right now, I'll use this rectangle to create my size of column. Now, for column size, for let me say residential building, the first column size that must come to your mind is 225 by 225 if it is for a one-story building. One-story building, you have to think of the first column size 225 by 225 first to come to your mind. Then during the design, if there is any failure, you can now begin to adjust the size of the columns which are not sufficient. So right now, in this case, this wall size is 225 by 225. But in your own country, since you say you guys use 230, so the first column size that should come to your mind should be 230 by 230, which is a square column. All right.
Yes.
Okay, so right now, since my wall here is 225 by 225, so I'm going to use a column size of 225 by 225, which is a square column. So I'll go here right now and click on this place, rectangle, and specify a place here and type my value 225, and I'll press this tab key icon, tab 225, and I'll press enter, as you can see it right now. So right now, if you dimension this, you can see that we have a 225 column by 225 column, as you can see it here. Okay, so I'll just take these dimensions off and then copy my column. So I'll copy this column right now based on the center point here, or this midpoint, and I'll copy it from there and then try to paste it at the center of this grid line. So with this right now, I have just established my first column point, as you can see it here. Now, when you're placing your column, let me say for every residential building, let for since you're starting for the main time, let your column distance should not be more than 6 meters. Can you hear me?
Yes.
Okay, since you're starting, let your column distance, that means what I mean by column distance, from this column to this column, let me say you can put a column here, it should not be more than 6 meters. Reason being that, one, um if your column distance is more than 6 meters, what happens is that the beam along that column will be having up to, like, the beam will be having at least a reinforcement of either 3y20 or 4y20 bottom. as the number of reinforcement. And most clients will not be able to afford that kind of amount of reinforcement due to the reason being that it is just a residential building. But if it is for, let me say, for shopping mall or for any other kind of let me say shopping mall, churches, and all that, commercial buildings, you can go as far as going up to 8 meters, 10 meters, 11 meters. But at least the maximum column distance um for like for a reinforced concrete building should not be more than 11.5 meters, knowing that the length of one full reinforcement is 12 meters, or most times 11.5 or 11.8. So I always advise that you should restrict yourself between 11 meters or 10 meters as your column distance if you're dealing with concrete, reinforced concrete. Once once a column distance is more than 12 meters, you should be thinking of to use a steel member, which is the I sections or I beam sections. That is what they call composite building, where you now have to mix concrete and a steel together. I don't know if you
Okay.
get me. Okay. So let your
Yes, I
column
do.
distance for every reinforced concrete building should not be more than um 11 meters, because the maximum length of rebar is 12 meters. Okay. So right now, since you're starting, I will say that you should not exceed more than 6 meters until when you have done more design and you have gotten a lot of experience, you can now begin to exceed up to 10 meters, 9 meters. Because the reason why I say you should not exceed for now that you're starting is because by the time your column distance passes 6 meters, you will be finding it difficult. No, okay, let me not say difficult. You need to apply experience to be able to manage deflection of that beam. Do you understand me? Hello, can you hear me?
Yes, I can hear you.
Okay, so right now, knowing that rule that let our column distance for the start should not be more than 6 meters. So I'll now use that rule right now and then begin to place all my column position. So I'll begin to place right now. Just copy from the center point now, and then I'll begin to place. So let me just place this one here. After, I'll have to confirm this distance if it is up to 6 meters or more than that. I'll also place this one here,
Yeah.
and then I'll just begin to place all my columns where I want to place columns first. Then after, when I begin to check my distance, I'll now know the ones I am to remove or where I am to add columns. Okay, so I'll just begin to place where I want to put my columns first. I want to place here and I want to put here. Now, putting your column position depends solely on you, which is the engineer designing the structure. Nobody will tell you where to put your columns. So, but if you know all these guiding principle, that let your column distance should not be more than 12 meters, or for now as you're starting, you should get yourself within 6 meters. I think that will help you a lot to be able to know how to position your columns. Then also, if you have a cantilever, as you can see that we have a cantilever here. Can you see that?
Yeah.
And also here also, the edge of your cantilever should have a column, because if I don't put column here right now, although this length of this cantilever is very small, but let me assume that this cantilever length is up to let me say 1.8 or 2 meters. Let me just say 2 meters. Let me add by 1,400. Okay, let me assume that this is 2 meters. If you don't have a column here at this point, what happens is that the load on this cantilever will be resting directly on this beam. And what happens is that there is what they call overturning moment. It will make this beam carrying this cantilever to what they call overturn. Simply means twisting. Just like if you like hold your hand. Now take your right hand and then hold your left finger and try to twist your hand. That is how it will happen. Because when the load, let me just say like this now, that this is let me assume that this is a beam. This is a beam, and then this right now is the cantilever. Let me change this to blue, yellow, and then there is a load coming up here. There is a load coming up at this very point here. Let me just use this. Sorry, there is a load coming up here now. Let me use this to red. Okay, so there is a load right now at the edge of this cantilever, knowing that cantilever carries its load at the edge here. Hope you know that.
Yes.
Okay, so with this right now, if this cantilever length is very long, let me say up to 2 meters, 3 meters, 4 meters, I've done the one of 6 meters before. So what happens is that if there is no column on this place to support this cantilever, or to carry, to like be able to withstand all what they call all the moments coming from this cantilever, and you have only a beam, it will make this beam to like twisting in the sense that when this load effects rises, bounces on this cantilever, which it will be like this, because this is how cantilever moment looks like, something like this.
Mm.
So if
Yeah.
it happens like this now, let me just use this color and then reduce this. If it happens like this now, it's not transferring a higher this deflection here will be based on the size of the load on this cantilever end. So at whatever effect that this load cost on this on this beam, it will not transfer all that effect to this beam here. So what happens is that this beam will tend to twist. Let me just use another color. So it will tend to twist this way. Let me use blue. Let me use okay, this one. To tend to like twist this way. There will be a twist this way. Can you hear me?
Yes, I can.
Okay, there will be a twist this way. And when there is a twist, what happens is that this point, which is called a point of zero moment, there will have to be a shear. It will not have to shear at this place. That means that there will like be like a break around this point, a break. This beam will tend to break at this point, and then when that happens, that is a collapse on that structure. So right now, once you have that kind of thing, I always advise you have to put a column, because since column carries its load vertically, axially, column will be able to withstand this load coming from the cantilever. The highest thing that will happen is that the size of the column will just increase to be able to carry that load from that cantilever. Okay, so right now let me just take this cantilever length back to what we have as 600. So 600 back to 1 4, that's 600. Okay, that's fine. So any questions so far for the thing I've done so far?
No, no, no. I can proceed.
Okay, so right now I'll just so always place column at the edge, at the point of your cantilever, just as you can see it here, just to be able for it to withstand all the stress coming from the cantilever. Okay, the same thing happens here. I also place a column here. At this point, we already have a column at this point here. Okay, so I'll just take off this right now and delete this. Okay, so right now, we will now begin to check our column distance, because the first thing we did was just to insert columns. So right now, we'll now go and check if it meets that principle. So I'll check from this column to this column. This gives me 5.15, which is okay. Since you're starting, I'll say you should get yourself within 6 meters. Okay, now this place right now, without me performing design, I've already known the kind of reinforcement that this beam will like carry. This beam will carry not less than 4 number of diameter 16 down and 3 upward. Okay, so I'll check this also on this other end too. Now you'll be able to know all these if you have done several designs. So when you have done several designs and you're following all the principles, without you performing let me say performing a design for a structure, once you see any building during construction and then you are not able to know the length, like you're not able to know the distance of the column, you should be able to know the kind of rebars or the reinforcement that beam along that line will be able to carry. Okay, so let me check this also from this point to this point. This gives me 3.2. And then so looking at this right now, I can see that none of our column is more than 6 meters interval in between them. So this is also 2.6. Let me check this one. Let me check this. This is 4.425. Let me check this. This look a bit long from here to here. Okay, this is 4 point something. That's fine. So from here to here. Okay, that's fine. So none of our columns is a more than 6 meter interval, as you can see that. So right now, once you're done with your column positioning, the next thing to do right now is to do what they call paneling. Paneling also have its own rule based on BS code or also Euro code. Now, paneling simply means you paneling how your beam and your slab should run. So looking at this right now, I'll begin to remove all these window symbol because I want to now begin to show how my beams will like flow or run. So I'll remove all the window symbols and then just stretch this down here and then stretch this down here. So invariably now, I'll also take this off also. Invariably now, I'm saying that there should be a beam along this line. So that there should be a straight beam from this point of column to this point of column here, to this point here. Okay, so right now I have just known that there will be a beam at this other place from here to here, and also there will be a beam from here to here. Now on this other side right now, I'll also remove this door. I'll take off all the doors and then begin to put my beams. So right now I'm trying to do what they call paneling, or what they call also, yeah, paneling. So I'll do that right now and do this also. Now, paneling has its own rule. Let me say I want to panel this place right now. Now, most people can choose to leave this also as a beam by taking it straight, by taking this as a beam here. But when you're doing your GA, which simply means general alignment drawing, you should carry two things in mind. One, the first thing is for stability of the structure, and two, also the other thing you should carry in mind is to also reduce costs of the building, because a good design, let me say a building that is stable but now has a very but is not cost, let me say the cost of the construction is very high. It is not it doesn't speak well for that engineer. So for you to be a good engineer, one, you should consider one, stability of the structure, and at the same time too, the cost of the structure. Now, what I mean by the cost of the structure, you can be able to reduce the cost of the structure when you know all the guiding principles. Now, most people that don't know guiding principle for like paneling, they'll go and leave this one here as a beam. But if I know the guiding principle right now, I can know that okay, from the BS code of practice, or from the or from even Indian code, Euro code. Euro code says that, or let me say BS code also says that the area of a panel or of a bay should not be more than 30 meter square area. What I mean by that is that if you have measured from this place to this place, if I want to take this right now as a panel, let me say I want to use this now as a panel. I want to use here now as a panel. I don't know if you know what they call panel. Hello? Hello, are you with me?
You said the yeah, I mean,
Okay, I want to
you're
know.
saying the maximum area for a panel is 30 square meters, no?
Okay, BS code states that the maximum area of a panel should not be more than 30 meter square area. So what I mean is that if you measure
Do you,
the
do you
if
have an
measure
idea of the clause, or I have to look it up?
I think you can check it out online. Just say BS. Okay, don't worry. After I'll send you all the clauses.
Okay.
Okay, yeah. So BS code states that the area of a panel should not be more than 30 meter square area. So what that thing means is that if you measure your length of your panel now, if I'm taking this right now as a panel, if I measure this length, this is 3.225 by this. Let me take this. This is what? This is 4.575. So if I should multiply these two together right now, you can see that they are, let me say calculator, QC, they should be around 18 point something, so or 15 point something, so 4.575 multiplied by 3.225. This gives me 14.7, which is very, very far away from our code. All right. So right now, if I don't, so with this right now, I can take this place right now as a panel, as just one slab here. Now, if I don't know all these principles right now, I'll go ahead and go and leave that beam that was here. Let me say that beam that was here. There was a beam here. I'll go and leave the beam that was here as a beam, of which which I will not have a slab here. I also have a slab here, and I also have this beam here. So what happens is now, just now, is that the cost of this beam is still there, which will also increase the cost of this building. But if I now apply that principle and then take off this beam, I have just reduced the cost of this beam from the build of this structure. I don't know if you get me.
Yes, I understand.
Okay, so right now I have just reduced the cost of that beam just now. Okay, so the same thing, I will now use the same principle to now panel all my structure, to now panel all these members. So I also check for this again here. We have a toilet here, and we have a maid bedroom here. So I'll check if this panel here can be able to suit in, or if it is less than 30 meter square area. If it is less than that, I'll just take off all these toilet walls and then take it off. So let me check that now, and then from this point right now to this point just now, this is 5.175, and then the width of this place, this is 3.45, which is less than that, because if you do that, it will give you around 17 point something or 16 point something. So with that right now, I'll take this off also. I'm coming. If you have any question, I'm coming. So I'll take this off also, and then join this together, join this, and then apply my beam here. The beam that will be here will not carry a wall load, because there is no wall around this. Around this one will not carry a wall load when we come to our design. Okay, so I'll just match up. I'll just change this to, let me use okay, I can use this for this color actually. So I'll leave that. So right now, or let me just use white for that color. Okay, that's fine. So right now I can now call this one. I can call this panel 1. So let me just change the name to P1. This is not my panel 1, and then this will now be my panel 2. This is panel 2, P2. Okay, I can take off this window symbol and then join this to this to form a beam, and then join this to this also. Okay, so the next thing to do again is to check this one also. Let me check this. For this now, I can remove this door and then have a beam along this line from here to here and from here to here. So by doing this right now, I have just formed this place here as a panel. This lounge here, this lounge as a panel, and this dining as a panel. I cannot go ahead to take off this and use here as a panel. It will be too wide, as you can see that. If you add this panel together and this panel together, they will be more than 30 meters per area. So I'll just leave that beam that is crossing here so I can take it here now as a panel, and this lounge alone as a panel. So let me take this off and then join this line together as a beam. Okay, and take this off also. Sorry, take this off, join as a beam. Now, most people just go ahead and go and begin their design and their modeling with the software. Now, if you don't do this paneling with the if you don't know how your columns are to be positioned here and how you're meant to run your panel, when you go to the software or Protastructure, you see that you spend much time because it is on that software right now that you now begin to think how you want your beam to run. But if you spend time to do your GA drawing here, by the time you export this plan to the software, you 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 already know how you want your beams and your slab to like to to be placed. So you won't spend much time again on your design. Like for me, I don't spend up to 10 minutes or 20 minutes on my designs. But I spend most of my time on my GA here because I want to first of all understand the plan and also know where to position everything. By the time I transfer this plan to the software Protastructure, you will see that we will not gonna spend much time. So okay, I'll do the same thing here by removing this door and then extending my line here, this to this. Now there should be a question I want you to ask me. Since I said that your area of a panel should not be more than 30 square area, what of if it is more than? What are you meant to do? Right? Hello, are you there? Hello, are you there?
Yes, I'm there. Yes,
Okay. So I said, what if your panel is more than 30 square area? What are you meant to do?
which means you'd have to divide the panel in split the panel probably into two, which means you'd have to introduce a beam and columns if necessary.
Okay, okay, that's fine. Yeah. When it's more than 30 square area, you have to do what they call internal beams on that area to be able to break that
Yes,
panel into two.
which are crossing.
Exactly, that's fine. Okay, so
So those internal beams will be carried by those other beams.
what is it? Yes,
Then
yes,
you'd
yes, yes,
also have to check maybe to see. You would
yes.
also have to check if those beams that are carrying the internal beams are they going to be able to carry the load, or you'd have to put some columns on the intersections if necessary.
Okay, that's fine. That's true. That's true. That's true. Okay. So right now again here, this is panel 6. So invariably, I have up to, let me check this if this place can be from here to here. This is 4 points. And from here to here, this is 3. I can take this off. I don't want to have this here. Okay. And then use here as a panel. Okay. And then this. So I can take this off. So I have panel 4. This has panel 4. And this has panel 5. Okay, so on this other side now, this other place here, where we have this curved slab, as you can see there, we can choose to run our beam straight to hit directly at this column here. While during the construction, they will use a block wall to form this shape of block from directly from the floor slab. I don't know if you get what I mean.
Yes.
Okay, so I'll just extend this beam right now and then take this curve off. Okay, extend this, extend this also. Reference, extend. Okay, and take this off also. Remove this. So the whole idea is just to try to prepare your plan to have at least a look of a structural modeling. And also, most times, building plan comes with their own grid line. So once you see a grid line from, let me say that the person that drew the plan place their own grid line. So I always say you should take off the grid line and then introduce your own grid line. There is what they call structural grid lines. So and then that is what they will like follow. So always place your grid line, but let it not be at least let it not be different from what they have, and also don't try to change the plan. So always work on the plan. Although you can change a window position if maybe there is a need that the column must be there and there is a window along that line. At that point, you can ask them to like change their column position because let me say, because you need a column at that particular point. Okay, let me just, so I'm almost done with this. I'll take off this right now, these staircase symbols, and then apply it as a void. Take off the staircase symbol, take this off, and apply it as a void. This should be a void. Okay, that's fine.
Where's the landing for this one?
What do you say?
The landing.
Here,
The
here, here.
portion for the landing, is it not supposed to be part of the?
Is here, is here, is here. There's a landing
Is it
here.
not supposed to show, or it's not going to show on that framing that we're doing now?
No, look at what I've done right now.
As the
I
edge of this.
I made the slab, the staircase area entirely to be a void. When we are done for the staircase, we will design the staircase landing with the staircase.
Okay.
Okay, so extend. Okay. Okay, that's fine. So basically right now, let me just reduce this to keep this here. Okay. So right now, once you're done with your GA on your first floor plan, there is what they call a superimpose. You have to carry your columns and superimpose it on the first floor plan. Remember, we did our GA on the ground floor plan, so you have to carry your column from the ground floor and superimpose on the first floor to see if there is to see the columns that will like that will proceed to the roof, or the ones that will also terminate on the floor slab. So yeah, so with this right now, I'll just go select everything here, right click and say quick select, and then select a layer, which is the column layer, and pick just the column. So this will pick only the columns for me, as you can see there. And then I will now have to do CP, copy. Now, I always advise, when you're copying your column, always copy from a place that is that is that is the same with the first floor plan. So looking at this plan right now, you can see that this point here, this point tends to be the same thing with this point, because there is no cantilever around here. But most times I advise you pick the staircase point as your reference point, because staircase doesn't change on a plan. Do you understand me?
Yes.
Okay, so if I pick this, let me say I want to pick from my staircase point now, I'll pick this point here, this particular point. If I pick this point now, I'll also do the same thing here and go and pick the point here. So looking at this right now, you can see that there is no column that is coming out outside. All the columns are all hidden inside the wall. But there are some plans that you like work with. By the time you've done what they call superimpose, you'll be seeing your column coming out empty space like this. Sorry, you'll be seeing your column coming out empty spaces like like this. So at that point right now, you will now begin to imagine or think of how to terminate the column and then transfer the column to any other point to be able to carry the first floor. But in this case right now, we do not have that. Although there will be another plan which we'll work with after this one, where you will see that where we don't have where the first floor where the ground floor plan and the first floor plan are not the same. They are very, very different. So at that point, we will now begin to have that kind of changes. I don't know if you get me.
Yes, I do.
Okay. So right now, since we have done what they call this we have incorporated this first floor column, this ground floor column on the first floor plan to see if there's any changes, and there is no changes. So with this right now, we can now export this to Protastructure. But before then, I want to know if there is any questions so far.
No, I'm fine. We can proceed.
Okay, so let me just take this to a column, and then this to column layer. Okay, so when you want to export to Protastructure, can you hear me? The first thing to do, you can see that we have
Yes.
different plans here, and what we want to export to the software is just this one. So we have to save this one separately alone. So by doing that, I have to select just the one I want to export to the software Protastructure. So I'll just highlight this and type W, enter. That W command will just save just just this one that we just selected. So right now I'll go here at this place here and then pick this point here. So I'll pick this point and then choose a place to save it. So let me just choose desktop and I'll just type the name of the file. Let me say one story building design. Okay, that's fine. And then the whole idea is for you to pick the file type. You can see that AutoCAD uses two file types, DWG and also DSF, to save drawings. Now, Protastructure requires you to save every file that you want to export to it with a DSF file. So you can see that we have DSF file 18 and all that. So you can choose any of the version, but it must be a DSF format. So with this right now, I'll just choose this first one here, AutoCAD 18 DSF. So DSF file, and then I'll just say save. So, and I'll click on OK. So by the time I click on OK, I'll go and confirm on the desktop where the file is. So in this case, this is the file here. As you can see it here, one story building here. So with this right now, we can now export to Protastructure. So with this now, I'll send this file to you for you to now begin the modeling. Can you hear me?
Okay.
Okay, so let me send you
Yes.
this file this file again now for you to begin the modeling. So I'll just send it to you again to your mail. Reply. Let me add the file. Okay. Okay. One story. Send. Okay, check your mail.
Okay.
Have you seen that?
Okay. Yeah, I've seen it.
Okay,
I'm
so right
downloading it.
now I will stop to cast my screen so that you can now cast your screen.
No, you just sent me a TWG.
Yes, yes. So you have to save it as I
You sent
save.
me it
Yes, so you save it, just save that particular file
as the TXF.
as yes, yeah. So I'll stop casting now while you cast.
Okay.
Okay, so share your screen.
Okay, just a moment.
Okay. Okay, that's fine.
Okay.
Okay.
Can you see my screen?
Yeah, I can see that. So save
Okay,
it
so
now. Save this one now as a DSF file, just that one as DSF file.
I have to select this one
Yes.
and it's
W enter.
W enter.
Yeah, W enter.
Okay.
choose choose this icon. No. This icon here below it. You will see these three dots. Three dots by where you have fire, that dot there.
This one,
Yeah,
file
that.
name.
So choose where to
Okay,
save
then
it.
I have to select the.
No, choose to
Let
save
me
it on
just put
desktop
it on the
first.
desktop also.
Then select DSF
Yes.
and put the file name. It may be one story building design.
Okay, DXF. Let me just say 2018 DXF. Then one story
Yeah, okay, yeah.
building design. Okay, then I save it.
Okay, that's fine. Then okay.
Okay, units.
Yeah, choose that place.
Units is
Millimeter.
being feet.
Millimeter. Then
Okay,
okay it.
everything else is fine.
Yeah, just say okay. Say what is here?
Include
Okay.
AutoCAD map.
Okay, you're using AutoCAD
It's
3D.
Civil 3D.
I don't
Just a
know.
moment. Check, please hold on a minute. A moment.
Okay, yeah.
Hold on.
Okay.
Oh, okay, sorry about that.
Okay. So I don't know.
Okay, you were saying okay, I'm using Civil 3D. Let me
Okay.
just do. Okay. No, I don't need map information. I can just say no.
Okay, so check on your desktop if that file is there.
Okay.
If this file
What
is
I
there.
need to do is okay. What I forgot to do is I'm supposed to choose drafting and annotation if I don't want anything to do with Civil 3D. You see now it's back to the AutoCAD display setting.
Okay, so I think you can do this. You can do it again
Okay.
now. You can do that savings again. Maybe save it again.
I wanted to check. It's there already.
Okay, it's there.
It's there already.
Okay.
Yeah.
So now open the software Protastructure and then import it.
Okay. Protastructure. Because I didn't install it as AutoCAD. I use Civil 3D, so AutoCAD comes part of Civil 3D as part of Civil 3D.
Okay.
Okay. So let me put it on this screen that I'm sharing. Okay,
Yeah.
can you see my starting page for Protastructure?
Yes, I can see it now.
So which means I have to select open a new project.
Yes. Open new project. So click there and type new project. Then type the name one story building design. Or let me see. Yeah, one story building. That's okay. Okay. If you want to use, can you hear me?
Yes, I can hear.
If you want to apply space, you can use shift underscore or shift a minus key to apply space between those story and building and design. So
Okay, because this one doesn't allow me to use
to put, yeah, exactly. So you
space
can,
bar.
yeah, so you can apply all that.
Okay,
Okay. So say okay.
then I do open.
Then you have to choose your
Okay,
code now. Which code do we
then
want to use?
uh, let's use zero code.
Okay, now so choose a Euro code, then say import. Choose Euro code and then say import. Okay. I'm not seeing the screen, so you have to share that
Okay,
screen.
it's another screen. No, it went to another screen.
Okay, that's
No,
fine.
it's back now. Can you see it?
Yeah, it's fine. I can see that now.
Because it had gone to the other screen. Yeah.
Okay. So right now, you can see, click on the file, click on file, that file icon there.
File.
Then go to model file import,
Uh,
model file import. Then
Model file import.
go to external reference drawing. Then click on
Yes.
DSF, and then locate the file where the file is.
DXF load.
Yes, click on that place, DSF load. Click there, and then go and locate the file
And
where
now
you
go
took the.
to my desktop,
Okay, that's fine. That's it, fine.
which is this
And
one.
then click on open and wait. Then just click on OK. Okay, that's fine. Okay. Okay, now click on use color. Use color. Check that use color. Check the use color.
Use the XF color. Okay.
Yeah.
Yes.
Now click on import members. Now we now want to import that grid line and the column axis into this place. So they will now convert to column element and also axis. So click there first. Import members,
Import members.
and then check that import
Um,
axis as grid and import column as column. So check those two. Okay, that's fine. And then click on OK. Click
okay.
on OK. OK. Just say cancel at that place. Yeah, no, yes, cancel on this other side. Cancel. Yeah, cancel that. You can cancel that one. There's no need for that. Then okay, now you can now close. Click on close. Okay, so with this now, zoom in. Let me see. Zoom in. So you can now see that we now have our columns already positioned and also our grid lines already positioned. So now we now begin to now if you check on your 3D view, check on 3D view. On that view on your structure tree, you can see that view there. No, not there, not there. Go out from there. That place where your mouse is now. Go. You can see view.
Yeah.
View. No.
Okay.
Go up. View. Just be going. This empty space where you have that blue highlights around there. No blue highlights. The top left corner of your screen.
Top left. Okay. Under views.
Yeah. Under views. So click on that view. Right click and say you will see 3D view. Right click there, and then you
No. There
no
is
right,
no 3D view here.
no right click. Right click.
Okay.
Yeah, 3D
Right click.
view. Exactly.
3D view. Okay.
So if you want to navigate through 3D view and plan view, that's where you can do that. So now click back on
Oh,
the.
okay.
So now click on the plan view back. You can see plan view there again. Click there. Okay, that's fine.
Okay.
So right now you can now see that we now have our columns and also our grid lines. Now we now begin to insert our beams. So to now put in our beams now, you got to click on concrete member at the top there. You can see member at the top there, concrete member at the top.
Concrete member.
Yes. So we are done with our column. Now now you can see that we have a wall there. That wall that you're seeing there is basically concrete wall. If you're designing for what they call, let me say, a lift. I don't know if you know what they call a lift, or let me say,
Yeah.
yeah, that's when you can use that
Lift
wall.
shaft.
Exactly. But for now, this building does not have that kind of um, um, lift or wall. So we now move to concrete beams.
Okay.
So go to concrete
Concrete
beams.
beams. Concrete beam.
Yeah, click there.
Yeah.
Now a dialog box will appear for you.
There it is.
Now, okay, now you have to impute your width of beam and your depth of beam. Your width of beam should be the same with your width of wall or your width of
Your
column. Yeah. So that B, where it's seeing B at 250 should be your width of beam. So in this case, it is 225, which that's what we use.
225.
Now your depth of beam, your depth of beam at least minimum listen that you should know is 450. That is the lowest depth of beam that at least you can first of all assume is 450. Then if there's any failure, if the depth of beam is not okay, we can now go and increase it after design. So type 450 there.
Okay. 450.
Yeah, 450, and then begin to insert right now. So click on one of the column and click on the next column to begin to insert your beams. So just as you can see the shape there, that's how the beam will like run. So begin to draw that shape based on the beam. So click on there and click on the next column. It will now insert the beam for you. Click there. So do the same with that by just following the shapes how they are. Click. Okay, that's fine. Now, so sorry, hold on. Can you hear me? Hold on. Can you hear me?
Yes, I can.
Delete, just to delete, just say escape first, escape, and delete that one. That one right
Escape.
now is acting like a cantilever beam. Just escape and
Oh, okay, okay.
let me see your 3D view on that place. 3D view on that. You see that it's acting like a cantilever beam. Say 3D view. Go and click on 3D view. Yeah. Then look at that place right now.
Okay, so I need to delete this one.
Yeah. So can you rotate here? Try to rotate. To rotate, use your hold down your left click or your right click, and then rotate your mouse. Your right click. Yeah, that's fine. So you can see that that's acting like a cantilever beam, which is not okay. So go back and then delete that beam and make it to lap to like support itself on the other column. Delete.
Okay, so I need to delete this one. Okay.
Okay, now go back.
So, okay, let me go back to my plan.
So
So
with
I
that
need to,
first, can you hear me? With that, you have to first of all delete this other beam first before you can add put that one. Delete that one first and then start the one that will carry it first.
okay, okay,
Okay,
okay.
that's fine. So put the beam first. Else, if you don't do that, they'll be showing you questions. Do you want this to be do you want it to be a secondary beam or that? So just to avoid that, insert this one first.
Okay,
Okay,
okay, so I can insert from this column
exactly.
to this column.
Now click on
Then I
escape.
have to escape
Then from here to here, exactly.
from here.
To here to there. Yeah, that's fine.
Then I escape again.
Then from there now to this place here. Exactly. Now, just to be fast, can you hear me? You can click on that one and click on the last column. To the last column, it will
Oh,
divide.
is it going to separate them?
Exactly, yes, it will do that. So click on the last column. That's fine.
Oh, okay, yeah, yeah, yeah.
Then do the same thing for the other
Yes.
side. Okay, that's fine. Then escape.
Okay,
Escape and do the intermediate ones.
the,
The internal beams, yeah,
the
internal beam.
inside one.
Yeah.
And this portion, but I think
Say say no. If you say yes, it will divide the beam on that place where you have that cantilever. Now, escape first.
okay. So which means maybe I was supposed to
Put
start with this beam
yes,
before I put this
exactly.
one.
Exactly. So right now, escape.
Okay, so I
That
need to
mark.
delete this one.
Sorry, hold on first. Hold on. That mark you're seeing there, that triangular mark, shows that that beam is a cantilever, which is not supposed to be. So delete it and then put it again.
Okay, okay. So that's what this mark means.
Yes, that's what the mark means.
Okay.
Okay, that's fine. So right now we are done with our beams. We now begin to insert our slab. So go the same way again, where you have your concrete
So on
member.
this one,
Okay.
okay, sorry. These beams here, was it not possible to incorporate this small panel into one of these panels?
Okay, that means we need to put a column at this point where you have with line 4. At this point, no, that place that you remove that mark,
This one.
yes, there should be a column there to be able to so I think we should shift this column that is here to that place.
This one here.
Either that one, yeah, that's okay.
This
If
one to move it here.
exactly, so
Or maybe move this one to
exactly
there.
move this one that is vertical to yeah, to that place. So you have to delete the column now and that beam and then put it back. So take off the column from there,
So should I move it or delete it?
delete it, and then insert a new column. Delete, and then
Then conclude
yeah, concrete member, and then beam. Sorry, column.
concrete column.
Okay. Put the size 225 by 225. Put the size 225.
This one, is it saying, is it a circular column?
That's what I'm saying. Just put your size there. It will change. Put the size of a square foot in, and it will change to
225
by 225.
225.
Then make those ones 0. Those values there 0, 0, 0. Those values here are 0. That's what they call eccentricity. So the column,
Centricity, yeah.
yeah. Then now insert your column. It will insert.
Okay, it's going to be.
Now you have to now take off that beam on that line and then insert a new beam on that line. So take off. No,
I need to delete this beam.
not that one.
This beam. Yeah,
yes,
this
those
one.
ones. Those beams on that line. Take it off and insert new ones.
This beam here.
Yes, on that line entirely. On that line, take it off. Yes, that one should go off.
Yeah.
That one too, and then insert a new beam across that line.
Okay.
You'll be asked a question because.
So which means I need to remove this one also.
Exactly. Or okay, leave it. Then when you ask a question, when they ask a question, just say no. It will just insert it as a primary beam.
Okay.
Okay. Go to the end. You can go to the end. Okay, yeah, sorry.
Are we not leaving it open?
Yes. That's fine. It's okay. Say no.
Then I say no.
Yeah, exactly. Okay, that's fine now.
Okay.
Okay, so then okay, now begin to insert your slab.
So our beams and columns are fine now.
Yeah, fine. So
then
if you take on a 3D view, slab.
Okay. If I check on my 3D.
Yeah,
okay.
That's fine. That's fine now. Okay. So now go and put in your slabs.
Slab, yeah. Okay. I've got my depth.
Okay, now
Can you hear me?
Yeah, can you hear you now? Choose your slab thickness. Minimum should be 150. That's what we although most countries like a US uses 120 as their minimum, but BS code specifies that your minimum depth of slab should be 150 millimeter. So you can see that place where you have H 120 should be 150.
150.
Okay. Now click on loads.
Concrete cover 25%.
Yeah, cover is okay. Click on loads. Now on this load right now, you need to insert your dead load and your imposed load. Dead load comprises of partition load, finished load, and all that. So I always advise to use 1.5. Why I got 1.5 was that finishing load should be 1.0, then partition should be 0.5, which makes it 1.5 as your dead load. I don't know
if normally your finish is 1.0.
Yeah, 1.0. Then partition load should be 0.5. So if you add it up together, that gives us 1.5.
Okay.
Yeah. So the dead load should be 1.5. Yes. Then for the area of the imposed load, just right click on that place, right click there, you will see several type of building. So right click on that place. So right now you can see that if you're designing for a normal building, like let me say residential building, you have to use that first one, general domestic use. If it is for classroom, I think classroom should be there also, hospital, banking hall, office area, school. Yeah. So right now we are designing for normal building, which is for residential building. So you have to choose that first one, general domestic. No, that first one. Yeah, that first one. Okay.
Domestic.
Exactly. Okay. So that's all you have to choose for your slab. Then you now begin to click on the panels, and the slab will just insert automatically.
Okay, which means I just go to the center.
No, just
column center.
No, just click on this on the panels, center the panels. Yes.
The center of the panel.
Yeah. Okay. But where you have staircase, don't put slab there. That place should be void.
And here, this one is a void.
Yeah, okay.
Okay. Oh,
Okay, now click on escape. Let's now begin to model for our cantilever slab because we have cantilever slab there, right?
okay. Yeah. This portion and this portion.
Okay, so right now we have to offset that grid line 1 to the point of the cantilever. I don't know if you have seen that grid line. You can see that that cantilever edge doesn't have a grid
Grid
line.
line 1.
So click on
Ah,
that grid line and offset. Click on it and right click and you see offset. Click, right click and say offset.
offset.
So zoom
Offset
in. Yeah,
axis.
yeah, offset axis. Click on it. Now zoom in and click at the edge of that place, cantilever. Click at the edge. Yeah, click there. It will take the,
Yeah.
yeah, click
Ah,
there. Okay.
ah.
So right now we now want to insert our, now escape. Escape. Do the same thing
Okay.
for the other
I
one
did
also,
escape.
for the left hand side. Click on that place, offset to that point. Click at the edge of that place. No, click at the edge. You see here, that place. At the edge of the place, at the edge. That's fine.
Yes.
Now escape. Now, we now begin to insert our slab. Go to the slab again. Concrete slab.
Mhm.
At this point, right? Sorry.
Yes, I can hear.
Okay, you can see that all the parameters has changed. So I think what you do, escape first, so that you know it's our time to choose the parameter again. Click on one of the slab and right
Okay.
click and say properties. Let's take that property of the slab. So no, escape first, escape. Now click on one of the
Okay.
slabs. Right click and say properties. Let's pick all what you have set for that one, properties. Okay, that's fine.
Okay.
Now to insert a cantilever slab, you see that place where you see type under labels, you see type.
Under label.
Before the no, up before the depth of the slab. Yeah,
Oh, okay.
yeah,
Type, yes, there's type 1.
yeah. So now click that place. Click that place. To now put a cantilever slab, you need to choose type 12. Type 12 is for cantilever slab. While type 1 is just for a normal slab. So choose type 12 for a cantilever slab.
Type 2.
12.
Oh, type 12. Yeah.
Yeah, type
Okay.
12. So choose that. Now, on that, now you can see that you now have other places to put values. You can see that L cant. L cant means length of cantilever.
Okay. Yeah.
See that? Yeah.
That's
So
fine.
put in the our first length here is 900, right? So put in the place, put that place 900 for our cantilever length. Then on the loads, on the load, click on load right now. There is what they call cantilever load. Click on the load tab. You can see that we have parapet load now. Parapet load.
Yes.
Now that parapet load simply means cantilever load. Like as I showed you before, cantilever load used to be at the edge of the cantilever, as I showed you from the beginning time.
Yes.
So we now have to impute that wall load right now on this cantilever. Now wall load is 9.81. I will show you later how we got that load. So put in this place right now, parapet load as 9.81. I will
9.81.
yes. I will show you that how we got the load later. So put in 9.81.
Okay.
Then now begin to insert the cantilever slab. To insert that, can you hear me?
Mhm.
You have to click on one of the
Yes, I
columns.
can hear.
Click on one of the columns now, and click on the next column, and then click outside.
Okay.
No. Click on the next column, not that one. Next column, just after that one. Yeah,
Next column.
exactly. Then click outside. Click outward. That's fine.
Okay.
Do the same thing for the next one. Yeah, that one. That column to the next column. Okay, that's fine. So that's where we have our cantilever, right?
Yes, but now why? it like on this portion, it's coming to the center of the column.
Yes,
Is it
yeah,
not supposed to go to the edge of the beam? Yeah.
yeah, I know. I will show you what if you want to do that, you have to um stretch that, extend that grid line to the edge of the column. But I will advise that's still fine, because during the construction, because during design there are some things you might not take into consideration, but when
Okay.
you're doing your slab detailing, you can now choose to show it how it should look like.
Okay.
Okay, yeah. Okay, then do the same thing for the other
But
end.
when you're analyzing it, you can put it on the
Exactly.
center line, on
Exactly,
the center
exactly.
line.
So during the slab detailing, you can now adjust it. So now go and change your distance to 600 for the other side. 600 thickness. Yeah, length of cantilever, length 600 for this other side.
Yes, I'm doing the other side.
Okay, that's fine. Column to
Everything
column.
else remains the same.
Yeah, column to column. Then pick outside. That's fine. Okay, now go and check your 3D
Yes.
view. 3D view. Escape and take a 3D view. Okay, that's fine now. So you can now see how the load is, right? Zoom in, and then rotate. You can now see your cantilever load. Okay, that's fine. Have you seen it
Yes.
now? Cantilever load. Okay, that's fine. That's fine. Okay,
Yes.
so right now we have inserted our slab, column, beam, and cantilever slab. So now time to go and insert our story. So go back to your plan view. Okay, to your plan view just now. Now to insert story right now. So to insert story, click on the tab. You see building setup at the top there. Top building setup.
Building set out. Yeah.
Then you see insert story. Click
Okay.
there.
Inside store.
Yeah. Now this software takes ground floor to be story one. So now you're gonna put story two. So if you're designing for a one-story building, you have to put story two. For a two-story building, you now put three. So right now you can see that we already have story one
Ground
active.
floor is story one.
Yes, while the first floor is story two. So you have to put the number of story now to be two, and then click on OK.
Okay. So total number of stories is 2.
Yes, it's two. Then click on
Okay.
OK. Then click on yes. Yes. Okay, so we now have our story two active. So we now have to go and import those beams into this story two. So click back on story one, make story one to be active now. No, story one, that's story zero, that's foundation. Story one. Double click on story one.
Okay.
Okay, that's fine. Now go back to that place again, building setout at the top there, and then click on generate story. So we are trying to now copy the column and the beams onto the story two. So click there. Okay, now you can see
Okay.
that we have a source story and also a target story. So our source story is story one, our target story is story two. Now click on the target story, click on story two on the target story. Now
Okay.
remove all the slab, check out all the slab, because right now we don't have slab at our roof level. We will be using a roofing sheet for the roof, so we don't have to use slab. Okay, so right now click on OK.
Only the slabs are
Yeah,
removed.
just
Yeah.
the slab, only the slabs, leave the
Rip,
rest.
no, rip the slab.
Okay, that's
And
fine.
the gates.
No, you can leave that. That's for steel if you're doing for steel. So only take off the slab.
If I have still. Yeah.
So click on OK right now.
Okay.
Okay, that's fine. And then click on
Process completed.
close. Yeah, close. Now check your 3D view and see what we have done so far. 3D view, yeah, that place. Okay, that's fine.
Yeah.
Now, since we don't have slab at this roof level, we are meant to reduce the depth of the beam from 450 to 300. So we'll just subtract the depth of slab, which is 150, and we are left with 300, right?
Okay. Yeah.
So right now, go back to plan view, or no, just stay here, just stay on this view. Go to your story 2, make your story 2 active, click on story 2 active, make it active, it will be okay, that's fine. Now go to your beams, under that story 2, right click on that, right
Okay.
click there on that beam, right click,
Right click on beams.
yeah, right click, and then go to beam table, yeah, sorry, summary table, yeah,
Summary table.
yes, summary table, click there. It will show you a dialog box containing all the beams. You can see that. Now you can see where you have
Yes.
H button, that 450 H button. Click on that
Mm.
H button at the, yeah, that place. Now you will see up, you see something like a pencil with a paper. That's what the column wise. Click there.
Yes.
Yeah,
Ah,
click there. Now type your
along with it.
new depth as 300. Have you clicked there? Click that place. It should show you a dialog box.
Oh, okay. No, it came on the other screen. Let
Okay,
me put drag
let
it
me
here.
see that. Let me see it. Okay.
Uh, okay, I can't move it to the other screen. I don't know why it can't move,
Okay.
but I
So
can type it
okay.
here.
Type there 300.
I can type 300 and okay.
Okay, and okay
Okay.
it. Yeah, okay it. Okay,
Okay.
that's fine. So it has not changed. So you can see that your column, your beam depth now have not changed on this other side. So click on close. Okay, so
Okay.
whenever you don't have your slab on the roof beams, you have to subtract that slab depth from the beam, from that roof beams. All right.
Yes.
Okay, that's fine. So right now, we go back to plan view for us to now adjust what we have. Because this place carrying cantilever slab, we have to extend the beams on that area for this level. So go to your plan view. Okay, that's fine. So right now, we have to
Okay.
now extend, apply a cantilever beam. So let's begin with this area of 600 cantilever. Can you hear me? Okay, now inside the cantilever
Yes, I
beam,
can hear you.
put a cantilever beam from this column outside, concrete beam. Okay, now, yeah, so draw it out from this column of column 2C13 out to the cantilever. Can you zoom in? Zoom in, let me see.
It's in
Zoom in, let me see. Yeah, from that place,
2C13. Yeah.
yes, outside. Click there and the, yeah, outside. Do the same thing for this column 2C9, 2C9, 2C9. Okay. Then join it together with the beam. That's fine. Yes, yes. Now make it to flush. We want that now. We want that column beam to flush with the grid line. So on this other place which have beam properties, you can see that around this H top. Can you see that? Take your mouse there. Let me see. No, 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 no. On the dollar box that is showing right now, you see H top, right?
Ah,
H top.
yes.
Now you can see that
This one.
there is a tab, there is a button at the back of that H top. A button. Click on that button right now at the back. Okay.
Yes, this
Yes,
one.
click there. Click there.
Insert option.
Yes, option. Click there. Now you can see that we have three
Yes,
options
I've clicked.
there. So we want to make this beam to flush with the grid line. So choose that last option, the last option, yes, that one, and then click on update. If you have choose that, it will make the beam to flush with the grid line. Click on update. That's fine now.
Okay.
Okay, now delete this beam inside. Um, Click on escape first, escape first, escape or close.
Okay.
Then delete this beam. Yeah, that beam inside.
Then
Yeah, did that because we have now made a new model. Take off the beam. That's fine.
okay.
Now do the same thing for the other side of the cantilever.
Okay.
A cantilever being out, you can just choose from grid line 1 and grid line F to put your cantilever beam. Grid line 1 and grid line
Oh,
F.
okay.
Yeah.
So I'm going to put a pin here.
Yeah, from that point to that point. Now make it to be a center. That place where you aligned it, make it to be a center. So go to that place and choose that place. Choose
Oh,
center.
now it's. I have
Yes,
to check this one.
center, and then click on update. That's update
Oh,
it.
maybe I did not escape.
Okay, okay. Escape first. Escape first. Now go back to that beam. Right click and say properties. Right click and say properties. Then choose that place now, middle and update. That's fine. So do the
Okay.
same thing for this grid line F. For this grid line F, grid line F. Okay, that's fine. Then now
Okay.
join it together, then change the option
Thank you.
to the first option. Use the first option. The first option now, yes. And update. That's fine. Now remove
Okay.
escape and remove the beam inside and the column inside too. Escape and take off the beam and the column inside. Take it off. That's fine. That's fine. And that one too. Now let's see our 3D view. Now also, sorry, come back. That circular column, change it to a that circular column there. Can you hear me? Go back to your
Yes.
AutoCAD and see that there is no circular column going upward. So go to your AutoCAD and see it out. Not that one, the one that will have our GA. Okay, the one that have a GA now. Now you can see that on this first floor here, we have only one circular column going up, and the two circular columns are not going up, right?
Yes.
So take off the two circular columns and change them to rectangular columns.
The rectangular column. Okay.
Yes. So go and change it right now. Remove it and put a normal column there. And put a normal column there, rectangular column there. Okay, that's fine. So insert a column there at the point there, at that point. That's fine. Same thing with the other one at the other end. At the bottom side. Yeah, that one. Take it off and put a rectangular column there. So right now, if you check on our plan now in AutoCAD, we have modeled what we have at the first floor because the first floor only have one circular column. If you check that, go to your AutoCAD.
Yes. This one. Yeah.
Okay, that's fine. Okay, so we have only one circular column. That's fine. So go back to your Protastructure right now, and then check on your 3D view. Let's see 3D view of what we have just done that now. Okay, that's fine. So
okay.
That's fine. Okay. So go back to your story one. Let's now put beam wall loads because all the beams on story one has a wall load.
Okay. Yeah.
So go back to your plan view, story one. Plan view. Story one. Click on story one. Make story one active. That's fine. So
Yes.
click on one of the beams and let's now impute our wall load. where I will show you how we got that 9.81 for our cantilever loads.
Okay.
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 So now click on,
Okay.
yeah.
Define.
Now click on edit beam wall load. Edit beam wall load. Okay. Are you there?
Yes, yes.
Okay, now on this place called unit, well, what unit width? Are you there?
All unit weight plus this one. Yes.
Okay, so the
Yes,
value
I'm
there should be 3.47. That is a constant value
0.47.
for all for wall of 230 or 225. For a wall thickness of 230 or 225, how we got that value was from, can you open your Google? Let me show you how we got that
Yeah.
value. Google.
Okay. I think I know how to calculate it.
Okay, because we got that value from the block unit weight and the plaster unit weight left and right. So if you add it together, you get that 3.47.
3.47 kilonewton per square meter.
Exactly. Okay, so go
Okay.
back to your
Let me
Prota.
just write it down.
Okay, so that is the wall unit
Um,
weight for 225 wall and for 230 wall.
Block, unit weight, and plaster both sides. Okay.
Okay, that's fine. So right now, you now put in your wall height. So your wall height right now should be, if we take
Meter.
our ground floor height to be 3 meters, so 3 meters
For
minus
them,
3 meters,
minus
right?
300.
Minus 300. So that gives us 2.7.
Yeah.
Because
2.7.
yes, because that block wall we stop at the beam depth. All right.
At that.
Okay, that gives us 2.7.
Yes.
Then
2.7.
now put in your wall thickness 0.225 in meters, 0.225.
Yes.
Are you there?
Okay. Yes, yes.
Okay, that's fine. So right now you can see that our dead load there is 9.37.
Kilonewton per meter.
Yeah. Normally that would have been the value that we had to put at that cantilever load. Can you hear me? But
Yes.
but the
Yes, yes.
reason why I used to use 9.81 is because if you multiply this 3.47 by 3, you will be having 10.41.
Yeah.
Okay, 10.4. That's what you
It
have.
is the,
Okay, so actually,
depending on the wall height.
exactly. So actually, most people used to use their cantilever load to be 10.41, or you can use this your 9.37. But me, I choose to use 9.81 because I don't want to use that 10.41. I don't want to be between the 10.41 and the 9.37. So I chose 9.881. You understand what I mean?
Yes, I do understand that. Yes.
So you can choose the exact value here, which is 9.37, or use the worst condition 10.41. So any of that. So that
10.41.
so anyone but me, I like to use 9.81. as my own cantilever load. Okay, so with this now I can now say okay. So once you say okay right now, that beam will now highlight. That beam will highlight as a canal. So if you check on your 3D view right now, you see that that beam has a wall load. Okay, so right now, go back to your plan view. As you can see that right now, that's a wall load symbol. Go back to your plan view and then copy that wall load.
Which one?
That one showing red, as if it's a red symbol. You can see the red there. Yes, that's a wall load.
This one with the dashed line here.
Yes, that shows that the beam has a wall load
Okay.
now. So go back to your plan view and then copy that wall load and paste on all the beams on the floor slab. Click on your plan view.
Okay.
Yeah, there. Now click on that beam and copy the wall load. Click and right click and say copy beam wall load. Copy beam wall load. Have you done that? Now,
yes.
On this your structure tree here, where you have your beam listed, yeah, click on the first beam here, on that beam 1, hold your shift key and click on the last beam. It will not select all the beams there. That's fine. Now, okay. Come out and then right click and say paste copied beam wall load. Paste, yeah, that's fine.
The wall load defined the selected beam will be placed.
Yes. Say yes. Click on yes. Now on the place where you have cantilever edges, click on those beams and remove the beam wall load on that area, because we have already transferred the wall load on the cantilever edge. So the place where you have cantilever, click on it and remove wall load. So just escape or click outside. Click outside first. Now click on the place where you have cantilever on the beams on that area, and then remove the wall load on the beam around that cantilever area. Like okay. Yes, because we have already transferred. Yeah, like this beam here. No, this beam here. This beam, yeah, that beam.
Which one? This
yes,
one?
Yes, that one. We have already transferred that wall load on the cantilever edge. So remove the wall load.
Okay, the wall load on this one.
Yeah, should be removed because
it's here on the
exactly.
And also these two here.
Exactly. So do that and remove the wall loads on that area.
So I have to click here and right click.
Yeah, right click and then say
delete beam wall load.
Exactly. Yeah.
Okay. Then I do the same here.
Okay, that's fine. Yeah.
Okay, and I do the same here.
Okay, that's fine. Okay. Now go to your 3D view and then check out that. You see how it looks like. Okay, now.
Okay, this one doesn't have. Yeah.
Okay, yeah. Now let me show you. I don't like the color that this software used to use. So you can choose to change your color for your members. So I'll show you right now. On this place where you have your vertical icons,
This one here.
Yes, so choose, click on that one, on the 10th icon, counting from up, the 10th icon.
This one.
No, sorry, 11th. Come down. The next, that one. Yeah.
Layer and color settings.
Exactly. So click there. Let's change our colors of beams and columns and slab and walls. Now on your column, you can see the column one there. I can see that. The column, you can see the column hash. Come down, you see column hash. Yeah, column. Click on the color for column hash. I like to use I like to use this magenta color that is deep. Or red. No. Choose on that color area. That one is too light. Choose the deeper one. Inside that place, choose the deeper one that is deep. No, go upward. Yeah, okay. No, come down and choose the thicker one. Come down. You can come down a bit. Come down a bit again. Okay, yeah. Up. Okay, yeah. That's fine. So click on and say okay. Click and say okay. Then for the beams, I like to use green. So go to the beams and then choose green.
The beam edge.
Yeah, use green.
Just the normal green.
Yeah, no, deep green. Use a deep green. No, no,
Maybe
no, no,
around
no.
these ones.
That's too thick. Come down a bit. Come down a bit. Okay, that's fine. That's okay. Or you go to the left. Go take your hand right, and then choose that one and say okay.
Right.
Yeah, take your hand. Yeah, that one. Then say okay. Then go to your slab. Say okay. Go to your slab and choose blue. Say okay first. Go to your slab A1 and choose blue. Go down. You see slab. Choose normal blue
Yeah, the slab.
or choose a sky. Yeah, choose that one. Choose a sky blue. A sky blue. A sky
Okay.
blue.
But this one
Yes, that one is okay. No. Choose, go upward and choose the one up.
up. Okay. How is this one?
Yes, and say okay. Okay, then go to your partition walls. Partition walls. Go down. You see partition walls.
Mm.
Partition wall.
Partition.
Then choose gray.
Partition wall H.
Use that black there. The black, no black, like thick, yeah, that one. Then say okay. Now, if you look at this place here, try to increase that your opacity, that volume, like a volume symbol. Increase it upward. Increase it a bit. Yeah, for that one,
On
increase.
the partition edge.
Yes, just yes. That one, yeah, that one. Increase the bit. Increase to the end or to 175. Increase to the end. Okay,
Okay.
that's fine. That's fine. Now say okay. Just say okay. Final
Okay.
okay. Now it will change. Okay, that's fine.
Oh,
Okay,
okay.
okay. Okay, so right now I will be following you up with my phone because my system tends to go off. So I will join with my phone right now. As you can see, you can see that we now have myself on my phone. Are you seeing
Okay.
that? Okay, so let me just go out. Okay, so I'll go out from my.
Yes, I can see that.
Okay, that's fine.